Okay, so the horizontal line test is if you are looking at the original function, and you, oops, it's frozen. You're looking at the original function, and you draw a horizontal line. Like they have a cubic right here where they've drawn a horizontal line. They have a quadratic where they've drawn a horizontal line. If it passes the horizontal line 2 times or more than one time, I should say, more than one time, by the time we do the inverse and everything switches, it will fail the vertical line test. So if you want to look at the equation ahead of time, before finding the inverse to determine if it's a function, then you can use the horizontal line test. So it does say to use your graphing calculator to determine, I'm going to use Desmos real fast, x to the 4th minus 4x squared. Depending on how fast our service is. Okay, so here is the curve in Desmos, x to the 4th minus 4x squared. And if you use the horizontal line test, and you know what, I'm just going to graph a horizontal line. If we use the horizontal line test, any horizontal line at all, you can see that it is going to pass more than once. So when I make the inverse of this one, it should not pass the vertical line test. How do I make the inverse? You guys watched my first half of the video. How do we find the inverse, like algebraically? Switch x and y. So this one right here, I didn't have a y in it originally because you don't need it for Desmos, but there we go, there was a y. So this one I'm just going to write x equals, and I'm going to write y to the 4th minus 4y squared. And you can see it did the inverse for me. I didn't even have to switch it so it says y equals. In your assignment, you do have to make it say y equals, okay? But on Desmos, you don't even have to do that. On your graphing calculator, you do have to do that. On Desmos, you don't, which makes me love Desmos a lot. But that is symmetric in the y equals x line. If I type y equals x, you can see that it's a little bit hard to see because there's a lot of stuff going on here. You can see that if I folded, we'll look right up here in this corner, if I folded on that purple line, the red and the green would match up. Okay. So back to the rest of the notes. So this is not a function because it fails the horizontal line test, or you could say it fails the vertical test after the inverse is created. I'm not going to really ask you guys why or why not. It's more about, is it a function? Okay. Example 3, consider the function f of x equals 2x cubed plus 1. We're going to determine whether the function f is a function, I did not read it correctly, where the inverse is a function, and then we're also going to find the inverse. So there's a few ways we can determine if it's a function or not. We could just sketch a graph using transformations. I know that it is a cubic, and then this cubic is moved up 1, and then it just has a vertical stretch. So it's just going to rise up faster and fall quicker. It's still going to have that basic cubic shape. There's no other things going on with it. So would this pass the horizontal line test? Yes. So yes, the inverse is going to be a function. Now, we're going to find it. So first of all, we need to put y in it. So instead of f of x, I'm going to write y equals 2x cubed plus 1. And then we are going to switch x and y. X equals 2y cubed plus 1. And then we're going to solve for y. So the pink one is the inverse. I've already found the inverse. I've done it. But we are going to solve it for y. So now I have x minus 1 equals 2y cubed. Divide by 2. Get y cubed equals x minus 1 over 2. How do we get rid of a cubed? Cube root, right. And when I do cube root, do I need a plus or minus like I do with square root? No. Any odd roots, you don't need a plus or minus. Every even roots, you do. So if it's odd root, because we are allowed to take the odd root of a negative number. You just can't take a square root or a fourth root of a negative number. So I don't need plus minus. Now we have y equals cube root x minus 1 over 2. Is that my final function? My final inverse function? No? Why? Okay, because it is a function, we're going to put it into function notation. So I will have f inverse of x equals cube root x minus 1 over 2. Is that the final answer? Are you trying to read my face? It's not readable. So the answer is no, it's not. Now, this is the inverse. The entire inverse is in pink every single time. We're just rearranging it at this point. There's something that I need to simplify, which you might look at this right now and be a little bit confused, but there's something that I need to simplify here. This is actually saying, I'm going to write it down underneath using the y, because I'm going to run out of space over here otherwise. There's something right here that says if we have the cube root of a fraction, that is the cube root of the numerator divided by the cube root of the denominator. That's like an actual quotient rule for radicals that you did in Algebra 2. What's wrong about what I just did? What's my big no-no? Ava? We're not allowed to leave it there for it to be simplified. I mean, I can have it, it's there, but I'm not allowed to leave it there for it to be simplified. So we have to rationalize our denominator, and we rationalize our denominator by multiplying by a value of 1. It has to be the same thing on top and the bottom, so it doesn't change the value. It's just going to change the way it looks. Does anybody remember what we need to multiply by? I hear whispering, but I don't know who's. So can you tell me what to write down? Okay. So this is what most people are going to say, but I'm going to have to tell you you're wrong. And let's see why. Okay? If I do multiply, so I am going to erase. Those of you that aren't writing it down immediately, I'm going to erase. This is not 100% correct. If I multiply by the cube root of 2, on the bottom, I will get, oops, I want to do it in pink. I want pink. Okay. I will get the cube root of, what's 2 times 2? 4. Is 4 a perfect cube? So multiplying by the same thing might work if it's a square root, because then we'll get the number squared. But a cube root, you can't multiply by the same thing necessarily. We need to multiply by something, hold on, erase. We need to multiply by something that ends up having a cubed so that we can cube root it. Does that make sense? We need to multiply by something that has a cubed so we can cube root it so that those two things will cancel. And Ava, you think you know what it is? Yes, now I'm not going to write 4, but what I'm writing does mean 4. I am going to write the cube root of 2 squared. So there's 2 to the first here. If we multiply by 2 more 2's, we're going to have 2 to the third. So that's going to give us our perfect cube that we need. And that was something that, you know what, in Algebra 2, it was your first experience with it. Now in pre-calc, we should start to master that concept. So I'm just going to not write the I'm not going to rewrite the numerator until the next step. So on the denominator now, if I cancel out my cube root and my cubed, I just get a 2. And then in my numerator, I'm going to distribute that 4. So cube root 4x minus 4. And I'll just put my answer in a different color so it stands out. So we get f inverse of x equals cube root 4x minus 4 over 2. Think of that. Might be the hardest part about this is just remembering rules from Algebra 2. And if you need some help, that's why I'm here, so I can help review those with you. But I'm not going to teach them from scratch because this is not Algebra 2. All right, the next question. Oh, I'm sorry. So determine whether the inverse f is a function. I just told the teacher, anybody else looking at my paper, that I knew it was a function by writing it in function notation. You do not need to write a separate note. Yes, it's a function. If you write it in function notation, then you know it's a function. So the next one, consider the function f of x equals 2 square root x minus 3. Determine whether the inverse is a function, then write the inverse. Okay, so we've got a square root. Put it over here. I'm just sketching it, talk through it. Normally starts at 0, 0, but this has a minus 3. Where does that take it? To the right 3. 1, 2, 3. And then it's got a vertical stretch, so maybe it's a little bit taller than normal. So if I were using the horizontal line test on this, would that pass the horizontal line test? Then it will pass the vertical line test. This will be a function when we're done. Now we need to find it. So we've got y equals 2 square root x minus 3. Switch the x and y. And then boom, I found the inverse. That's it. But I need to solve for y. What's the first thing I need to do? Natalie, what should I do to start solving for y?
Divide by 2.
Perfect. Divide by 2. And I get x over 2 equals y minus 3 under a square root. And Stephanie, what should I do now? I'm going to square both sides because that cancels out the square root. So when I square the left, it will be x squared over 2 squared, or 4. That's a place where some people make silly mistakes. They forget to like square the 4, or I mean square the 2 and get 4. Just warning you guys, I know where people make mistakes, silly mistakes. And then finally, we will add that 3, and we get y equals x squared over 4 plus 3. So now I know that this should be a function, so I will put it in function notation. F inverse of x equals x squared over 4 plus 3. But then I'm going to tell you that's not the full right answer. I'll wait for some people to catch up. But I'm going to tell you that's not the full right answer. What shape does x squared divided by 4 plus 3 make? What is it? I couldn't hear you. What shape is this? Like what parent function? What kind of graph? Oh, quadratic, is that what we're saying? What's quadratic look like? Like a U shape. If I take, now I'm zoomed, I gotta zoom in more maybe. Come on. If I take this little graph over here that I drew on the side, if I take this little graph of the original function that I made in black and I reflect it in that line, is it going to be a parabola? Is it going to make a U shape? It's not going to make a U shape. And let's look at this point right here. What is that? 3, 0, so 0, 3. It'll look like this. That's just looking at the graph. So my equation says it's a U shape. My graph does not say that. What is right? What do you trust more? I already told you the equation's wrong, so you should trust your graph more. But do you know what we need to do? Zero. It'll be zero. Yeah, I know that's confusing, but I didn't give you the hard ones in the homework. It'll be zero. But yeah, so we've got this parabola where we only have half of it. Just like we have the square root, but we only have the top part. We only have the positive part of the square root. So the negative part of the square root wasn't originally graphed. So the negative part of the parabola is also not graphed. So this would be like the part where people make mistakes, is forgetting that these shapes have to reflect and look exactly the same. So if we have a square root, it's going to reflect a half of a parabola. If we have a parabola, it's not going to reflect to just half of a parabola. It's going to reflect to the whole thing. So you need to make sure that your shapes are matching up. Now, we didn't have to graph all these because of time, but in your assignment, you will graph all of them, so you'll be able to check that they do match up. Also, when you take a test, you'll be able to check because you'll be graphing them on the test. All right, now here is the most important part that you needed to hear. So this part, every single year, I have people that just don't listen to directions, they don't do it the right way, and they basically like miss this entire part of the test. What?
If we put if we don't put the X,
you get partial. Yeah. Now this won't be on the quiz, but it'll be on the test. Okay? It won't be on your quiz on Monday, but this stuff will be on your test because after the quiz on Monday, all we're doing is reviewing for our test. This is going to be on the test. I'm not going to quiz you on just one section. Well, I guess I am doing that with 1-6, but 1-6 was a big section. This is going to be added onto your test, and the first time you're going to get truly assessed on it will be, besides your homework, will be the test. So what I've had people do in the past, and they're usually people that don't spend a good time on their homework, is completely ignore the directions and just do what they want. And then they missed all the points. So we're going to follow our directions. This says verify. And the fact that it says verify, we have heard words like this before: justify, verify, I don't know, prove. Have you heard that word before, maybe in geometry? I didn't hear any groans. Have you heard this word before? When I say prove, does that bring up bad or happy memories? Half and half. All right, so what prove is going to mean is we're going to show all of our steps, and we're going to follow the directions in which you are supposed to prove it. You're not going to make up your own side proof thing. We're going to follow it this way. It should be easy points. Okay? What it says to do is in order to prove that in order to verify that these are inverses, you're going to show f of g of x is equal to x. Step 2, show g of f of x is equal to x. So we got 2 steps. Now I am going to color code these so you can totally follow along with what I'm doing. I'm just going to rewrite f of, and then I'm going to write g of x in a different color. And I'm going to do the same thing over here. I'm going to color code it. So g of is pink and f of x is blue. So every place that I do f of x, it's going to be in blue. Every place that I do g of x, it's going to be in pink. So you can kind of figure out where this information is coming from. So for f of g of x, we're going to start with our f equation. And what f of g of x means is replace, so these are notes. You don't have to write this every time, but these are notes. Replace x with parenthesis g of x. So that's what f of g of x means. It means take out the x, put in g of x instead. So I'm going to have my f equation, 3x minus 1. But I have to take out the x. So I wrote 3 parenthesis minus 1. Instead of x, I put g of x, which is x plus 1 over 3. See? I put the g of x inside of the f of x instead of the x. I replaced them. I substituted. Now we are going to simplify this. And this is where you need to show all your steps. You should not just have one step unless normally there's more than one step, okay? To simplify this, I'm going to think about my fraction inside. I always want to do what's inside the parentheses first. And there is an understood parenthesis up here. It says I have to add x plus 1 first before I divide by 3. Now I'm going to keep talking. I can't add x plus 1. I'm going to divide by 3, and the very next thing I'm going to do is multiply by 3. If I divide by 3 and immediately multiply by 3, what happens? They cancel. So I get x plus 1 minus 1. Now if I add 1 and then I immediately subtract 1, they cancel. Those are inverse operations, and we get equals x. And that's what we're trying to get. So check mark, yay! So this is verifying. Now we do the other side, g of f of x. So I will first have my g equation. X, which I have to plug something in for x, plus 1 over 3. And the reason why I write it all out first before I plug the other thing in is sometimes people plug the other thing in and just forget to write the plus 1 or the over 3. They just forget to go back and finish it. So I like to write that first. And then my f equation is 3x minus 1. And I will simplify. So by order of operations, I cannot do anything inside this 3x minus 1, but my next order of operations tells me that there is this understood parentheses up here that says you have to do everything on top first. So I have 3x minus 1 plus 1. Well, that's 3x. And then I bring down the divide by 3. And if I have 3x and I divide by 3, what do I get? X, good. So that also equals x. If they both equal x, then we have inverses. You've proved that they are inverses. Okay, let's look at the next one. So I'm going to keep color coding so you can follow along. I'm going to go ahead and keep the same colors even. My f of x will be blue. My g of x will be pink. We're going to verify, and it even says show that f of x equals x. f of g of x equals x. So we're going to go f of g of x. Now I'm going to take my f equation, 8x cubed. So instead of x, I'm going to take out that x, and I'm going to put in the g. Cube root 2x. Now we're going to work through our order of operations. We're going to simplify it, and hopefully it's going to equal x. So inside of my parentheses, I have a cube root. The entire thing is a cube root. Outside of my parentheses, I have a cubed. So what happens? Cancel each other out. Those are inverses, so I have just left over 2x. We multiply those together, and I get 16x. Does that equal x? Mm-mm. All right. So let's try g of f of x. Oops, g of x. If I could just stick with my colors, that'd be helpful. Okay, so my g equation is cube root, and I have a 2. Then I have my x, so that's where my parenthesis is going to go. And I'm going to go over and grab my f equation and put it in there. So here we go. We have to remember some stuff from Algebra 2 again. Underneath, I can multiply that first, 16x cubed. Now, can I take the cube root of 16? Is 16 a perfect cube? No. But 16 does unmultiply, what's the word, factor, to be 8 times 2, And from what we learned in Algebra 2 last year, hopefully we learned, I should say, is that you're allowed to unmultiply the roots. This got really messy over here in the corner, sorry. Oh, that's fun. You're allowed to unmultiply those roots, so we can take the cube root of 8, the cube root of 2, and the cube root of x cubed separately. So then I have the cube root of 8 is 2. The cube root of x cubed is x, and there isn't a cube root for just the 2. So this would be as far as I can simplify it. Again, does it equal x? No. So these would be not inverses.
So would it be just 2?
No, because of the x cube roots, but it goes on the outside and just becomes x. Yep. Yes, Courtney?
So it's not always going to be like this x? Well, so, like, say that
If it is inverses, it will.
Okay, but say if that one somehow equals like 16x2, would there be inverses? Or
No.
It's just always going to be x?
Yes.
Okay.
Yes, to be inverses. So in math, when we do inverses, let's say if we multiply by 2 or we divide by 2, can you guys tell me the answer of multiply by 2 and divide by 2? Well, they equal something, though. They equal 1. If I multiply by 2 and I divide by 2, they equal 1. Which, if you multiply anything by 1, it doesn't change the answer. If I add 2 and I subtract 2, they equal 0. And if I add 0 to anything, it doesn't change it. So this is kind of like that, only this is giving us the identity graph. This is giving us y equals x, which is our identity graph. Kevin?
What if 1 equals x? I like when you ever have like 1 equals x.
That's exactly what I was going to say next. And were you going to ask that too? What if one of the situations equals x?
Well, I was going to ask, like, from the jump, would you just say that they're not inverses? Like, would you have to do this?
Okay, so I'm going to answer both of the. That's exactly where I was going next. Anybody in here, 100% of the time, never, ever, ever make any silly math mistakes? Anybody in here just so perfect?
Oh,
It's like,
no. I thought you
wait.
were saying.
Okay, I'm raising my hand because I'm totally lying because I make silly mistakes all the time. You guys have made an arithmetic error once in a while, yes? So because there is no way that one will equal x and the other won't. So if you get one of them equaling x and the other one doesn't, you've done something wrong. All right? And yes, we're going to check it because if you make an error and the first one doesn't equal x, it doesn't mean you didn't make an error.
Okay.
So we are going to do both one time on the test. Okay? So now let's go ahead and try the last one. If you want to work ahead of me, I can stop talking for like a half a second. You can work ahead of me and see if you can do it on your own, the f of g of x part, and then I will go over it. I'm going to just start writing, but I'm not going to talk yet. Walking around, see how far you are before I go over it. Make sure you have, you guys see I'm putting, well, you can't see it right now because it's like scrolled, but I'm putting equal signs in a row so it's very organized. It's just like a proof. Okay? Don't make your stuff go all over the paper because it's not for you that you're doing it. It's to show your steps. It's the original one, yeah. And that's what happens is people forget to finish the original one sometimes. Did you? Okay, so negative, so you're going to do the F term. So negative, then a parenthesis. Oh, here, I was looking there. So negative, parenthesis, you put the G in there, and then 4 on the outside. So you can see up here what I did is I wrote the F equation before I even went and looked at the D, because people forget to finish writing the F equation and just do it all at one time. So that might help you if you're forgetting things. I'm going to go through it now. I'm going to finish recording it because I did see kind of the same mistakes. So I saw a lot of you in here that forgot to write the +4 immediately. So you can see up here, the first thing I did when I wrote f of g of x is I wrote the f equation, but I didn't even put the g equation in yet. So that's how I have figured out that I need to do it so I don't forget to write that +4. Okay, so I'm just giving that as a tip if you forgot. Now I'm going to put my g equation inside. Negative x plus 4. Okay, and then I'm going to simplify. So we've got inside the parenthesis, I can't do anything. Outside the parenthesis, there's two things happening. There's a multiply by -1, and there's a cube. What happens first, multiplication or exponents? So we have to exponent first. So I'm cubing a cube root. That cancels out, and we get negative x plus 4, and then bring down +4. So I left the parentheses there because I haven't multiplied by the negative sign yet. All I did was cube it. Now I'm going to multiply by that -1, which I have to distribute, and I get positive x minus 4 plus 4. And then you see how I'm copying my equal signs in a row each time so that somebody else who has to look at this and follow your work can follow your work. That's the whole point of doing a proof, is to have somebody follow your work. If it was about getting the answer, then the work wouldn't matter. This is not about getting the answer. This is about showing the steps. So now x minus 4 plus 4 is x, and that works. Okay, so as long as I didn't make a mistake, the other one should work too. So you see I already copied down the g, but I didn't put my f in there. So I'm going to put my f in there now, negative x cubed plus 4. I'm going to go inside of the radical, and I'm going to go inside of the parentheses. There's nothing I can do inside of this parenthesis. But the radical itself, the cube itself, cube root itself has a understood parenthesis. So I'm going to multiply before I add. I'm going to multiply the -1, and I get positive x cubed minus 4 plus 4. And then I will add the -4 and positive 4, and I get cube root x cubed. And the cube root of x cubed is x. So that worked. So we have inverses. Okay? So the two things you need to worry about here are actually showing your steps, and then don't make silly arithmetic errors. The last example I have on there is a repeat of stuff I've already done, so I'm not going to do the last example of notes. So that's it for the note video. Fingers crossed this one worked.